Hi everyone. In today's video we're going to look at F sharp. In particular we're going to look at the concept of values in F sharp, and yeah, since this is the first video where we're diving into direct coding, well, the advice I would like to give is that first of all, F sharp is a lot of fun. You will find out hopefully that coding in F sharp can be fun. Reading it is also fun as well. But more importantly is what I would just implore you is whatever ideas, if you're someone who has never done any functional programming before, or you've never coded before, you're going to find F sharp very, very easy to learn. But if you're someone who has a lot of experience developing in other languages, especially object-oriented languages, I would implore you to just whatever ideas you have about the languages you use, you should just don't move into F sharp with any preconceived notions. That would help you really get the language a lot quicker. And I will try my best to make sure that I point out the contrast between things that may seem similar to OOP concepts but are very different. So let's just jump right in. Yeah, first of all, you need to set up your F sharp environment. I have a video on that. You can just check the link in the description. I'll also link to it in this video. But what you need is to just have the .NET Core SDK. So if I say .NET version, you should see that I'm running 3.0.10. So anything after this version is fine. The reason why we're using .NET Core 3 is because of .NET FSI, right? So that's F sharp interactive. It allows you to just quickly write F sharp code. So you can say 2 plus 2 and see the output immediately, which is really, really cool. So let's quit that. So now that we've quit that, let's head over to VS Code. Oops. Yeah, let's head over to VS Code, right? So that we can launch this. Then first of all, we just need to create a script file. So we're going to say o1-values.fsx. So fsx is the file extension for F sharp script files. So what it allows you to do is just quickly write F sharp code and see the output. So let me, for example, I could just, that same 2 plus 2 I did earlier, I can just highlight this, use Alt Enter, and it runs it, and we can see the output here. Okay, so the first thing we need to look at is when we say let number equal to 2. This is how you declare a value in F sharp. This is the first point where a lot of people will just have misconceptions about the language. This you're looking at is simply what is called a binding in F sharp. A binding is different from assignment, different from variable allocation if you are experienced, but if you've never coded before, just understand that what a binding is taking a value and giving that value a particular name. So that's it's like naming a value. So what we're doing here is we're saying that we're giving 2 a name, and that name is number. And this means that for the entirety of the program, number and 2 are referring to the same thing. In other words, wherever you saw 2 before, you could replace 2 with number, and the meaning of the program would not change in any significant way. That also means you cannot come and later name number something else. So we can't come back and say let number equal to 5 or whatever. That will not work. Okay, to say that the definition of number, there's a duplicate definition of the value number. So this is really, really important. Understand that in F sharp, when you do a binding, you are binding a value to a name essentially. So we're saying let number be equal to 2. Okay, this is called binding and values and so on and so forth. On the other hand, you could have a variable as well. So let's say this is my variable, right, equal to 2. But this time I would say, because it's still a binding, say let mutable my variable equal to 2. These two things are very different, right? The first one is a binding, so we are binding the value of 2 to number. But in the second one, we are creating a variable, which is like a location in memory where we are storing the value 2. So we could come back later in the application and say my variable and assign it a different value. So let's say 10, right? that now means that my variable now has a value of what? 10. So let's look at it. For the first one, I can just say Alt Enter. You can see that it's saying that number is 2. That's never going to change. And now if I highlight these 3, use Alt Enter, you can see that it was 2 before, but we now assign 10 to it, and the new value is 10. Okay. But if I try to change the value of number with something like this, this will not work. Obviously you get an error. Say the value is not mutable, consider using the mutable keyword, the mutable number, blah blah blah. So that is the first understanding of values, right? Of bindings rather. You are binding a value to a name, not a variable. A variable is something different. A variable is a mutable value essentially. So what it allows you to do is to change its value later. So that's values and variables. Okay. So in F#, if you notice when I said let number equal to 2, you will see that there was this int that appeared here, right? That's because if you put your mouse on it, it tells you that it's an int. That's because F# has something called type inference. Type inference is very, very powerful. What it does is that whenever you declare a variable, whenever you bind a value to a particular number, whenever you bind a value, essentially it infers what that type of that value is. And there are different types of values in the F# languages. In fact, you can create your own, but we're going to look at our numbers. So the first type is integers. Integers are essentially whole numbers that it goes from minus 3 point something billion to plus 3 point something billion. So you could declare as many integers as you want, and int equal to 10 or whatever. You could also make it, you could also like explicitly give it a name. So we can just put this colon and specify the actual type that we expect this to be here, and it is essentially the same thing as this, right? Okay, so the second type of numeric values that we have in F# is floats. So if I came here and said number equal to 2.0, right? As you can see, it's already telling me that it's a float, and if you mouse over it, it tells you that it's a float. Now, what floats are? Decimal values. So they are 32-bit decimal values. Also, I think 64-bit, yeah, 32-bit decimal values. But you could just have like 2.0 number equal to, and again, I could also explicitly give it a value. Say a float is equal to say 2.5, right? Make it explicit. Say float 2.5. Yeah. So it's the same thing. You can also ignore the, if it's like this 2.0, you can also ignore the thing following it at the bottom. So that's for floats. So for example, the different types of numeric values that we're going to look at are things like ints. You can have floats, you can have doubles, you can have decimals. So these are the different numeric values, and you can just run them to see that they are all working. As you can see, there's 13 to 4 blah blah blah, and it works. Okay. That said, you can also convert between one type of value to another. So you would use this this shorthand. So you can say something like int a float. So we bound the value of a float to 2. So we can simply say int of a float to convert this to an int, or float to convert a double to a float, or convert an int to a decimal, which is really, really cool. But essentially these are just regular .NET types. Then as a result, arithmetic is how you'd expect it to be. So if I did something like this and executed this, so let me just highlight everything and execute it, you see that it came up with the answer of 8. So what we did here was just to take an int, divide it by 4, add 5, subtract 7, put all that in brackets, multiply by 4, and add a double that was converted into an int. So when you do that, it just throws away the decimal aspect of it. But as you can see, regular arithmetic works as expected. The next thing we're going to look at is Booleans, right? So Booleans are essentially true or false values. So you can say is true. Let's create a boolean, say is true, and we just say true here, true. Yeah, so as you can see, it's telling us that this is a bool. I can just come here and say bool as well, the same thing, and I say is false to be another bool to be false, right? Very simple. I could also like check, so I can, sorry, this should just be false. So I can also run some simple operations on it. So if I wanted to check is true or is true, right, the answer should be true. So this is the or operator. So if I should highlight all this and execute it, oops, I should get true as my answer, which is what I got. Then you can also have and, so you can use this as and, execute it, you get true as well. So if I say is true and is false, the both should be false. Okay, yeah. So this is just some basic Boolean logic. F# on the other hand doesn't have a not operator like this, like most languages do. Instead, we write it plain like this: not is false. Okay, that's true. The next thing we're going to look at is strings. So in F#, a string is simply a collection of characters, right? So we could have a string like hello world, like this, and when we run that, you can see it's saying that the value is a string of hello world. Very straightforward and simple. Typically strings are separated by quotes, and they are delimited by backslashes. So an example of this would be, let's take this string that we are looking at right here. So if you notice, VS Code is even coloring it for us. So whenever we use this means a tab, and this means a new line. So if I were to come here and execute this, you will see that yes, it said this is the first line of the string. It created some space, which is the tab, and then put the second line on a new line. So that's how you escape string sequences. This is similar to other languages as well. Sometimes you may not want this escaping behavior. So for an example would be something like this, right? In that case, you use what's called the literal string, and that literal string is you put an @ sign in front of the string, and then it ignores all backslashes, right? So if I were to come here and do /t, and I were to execute this, you would see that it still takes the /t as it is. So that's literal strings. Another problem is that you can't have quotes inside literal strings. So if I did this, as you can see, it's starting to give an error. So in order to fix that, there's something called, this is verbatim strings, sorry. So that's where literal strings come in. So for literal strings, you would use something like this. So you now have you use a triple quote to start it and a triple quote to end it, and then anything in between those triple quotes can have whatever you want. It can have quotes in it, it can have backslashes, it can have, new lines, whatever, right? So an example of this would be, if I were to run it, if I were to run this, you will see that we now have the literal string in quotes, 24 characters, whatnot, which is really, really cool. You can also concatenate strings together. So for example, if I had a string called greet, say hello, right, and I had a name, then I could concatenate hello with name with the plus operator. So you can say greet plus name, blah blah blah. So if I were to run this, you see hello-world. Okay, so we're done with strings. Next up is tuples, right? So a tuple in F# is like it's a value that holds two different values in it. So the values may not be related in any way, shape, or form. So for example, if I said something like a tuple equal to 1, ONE, right, you immediately notice that the type signature here is telling us int times string, right? And I will explain the reason for this later, but the point is here you just have a tuple value that has these two values in it. So if I were to go ahead and run it, you will see that it's in brackets and it's telling us int times string. The reason it's telling us int times string is because this type is a new type that if you think of all the possible values of these two combinations together, it would be all the possible values of int multiplied by all the possible values of string. That is why it's saying int times string here. So, but it's just a method signature that tells you that it's a type that contains two types in it, an int and a string. Okay, so that's what we're seeing here with 1, 1. Tuples are not only limited to just two values. Tuples can have more than one value. So you could say 2, 2.0, say TWO. So this is another tuple as well. So you could have multiple or as many things you want to put into the tuple as well. So it's just a collection of different items. They don't have to be related, but they just put into this one bucket. In F#, this is how you do comments. You just use two quotes, 2 backslashes. So that's one way of doing comment, and say this is a comment, right? A comment doesn't get executed by the compiler. The compiler just ignores it. You could have multi-line comments. So you could have with something like this. This is how you do multi-line comments. This is a multi-line comment in F#. Use triple comments as well. This is a triple comment. So these are the different types of comments in F#. So remember, I said earlier that when you had a binding, so you could say something like let a equal to 1, that this was a binding, not an assignment. Now this becomes very, very important because one of the different forms of a binding expression in F# is something like this. You have let and a particular pattern equal to your binding expression. Okay, so this becomes very, very important because now we could simply come here and use it to decompose the tuple. So we can say let a comma b equal to a tuple, right? And what the compiler would do here is to take the left hand side, which is the tuple, and then look at the pattern on the, take the right hand side, which is the tuple, look at the pattern on the left hand side, and then do the binding based on that pattern that was supplied. So we came here and said let a comma b. So what will happen is that the value a will get bound to 1 and the value b will get bound to the string one. So to prove that, let me just go ahead and run this. Right, you can see that a was bound to 1 and b was bound to the string one. This is really important. So if you thought this was an assignment, right, it would quickly confuse you the moment you saw something like this on the left hand side. So what is happening here, like I said earlier, is a binding. All right, another thing that makes this binding idea useful is, let's say I wanted to, let's take this code snippet at the bottom. Let's say I wanted to swap 2, 3 with, I wanted to swap the elements of this particular tuple. So what I can just do is to first decompose it in X and Y, and then just recompose it back with the values bound in a different order, and I get a new tuple. So let's run that. You will see that, yes, it's now 3, 2. Okay, so next thing we're going to look at is lists in F#. In F#, lists are simply sequences of items. For example, let's say we had a list. So let's call this list my list equal to, and this time we have 1, 2, 3, 4, 5, right? And once you highlight that and execute that, you get 1, 2, 3, 4, 5 as the content of the list, which is cool. Now in F#, this list is actually a linked list, meaning that it's actually each value is concatenated to the list at the beginning of the list. So I'll explain that later. But if you look at the type signature, it's saying int list like this, and there are two ways of writing it in F#. So one way is to write the type signature as this int list. Another way is to write the type signature as this list of int, right? The first one is the F# way of doing it, right, which came from OCaml and whatnot, and the second way is the .NET way of doing it, but both of them are fine. For the sake of this particular video, I prefer this int list structure. Yeah, so this list we are looking at, right, we can come here and say second list is the same thing as saying 1, 2, 3, 4, 5 and an empty list. So this operator, this is called the cons operator. What it does is it appends a value to the list, okay, and this one appends to another list, and so on and so forth. So if I came here and run the two, you see that the two lists are essentially identical, and to prove that point, I could say my list equal to second list, and if I run that, I should get true. Okay, so this is how lists are created in F#. So if I wanted to add something to the beginning of the list, I could just say maybe 100. I could say 100 my list, and that should generate 100 at the beginning. All right. A list in F# is immutable, meaning that once the list is declared, you can't change it in any way, shape, or form. You can't change any of the elements. You can add or remove from it. So every time you add or remove from it, you get a brand new list, essentially. So that's important to keep in mind. Lists also have the concatenating operator. So for example, if I did this and wrote these two lists, 1, 2, 3, 4, 5, 6, and I use this special operator, the @ operator, I can add two lists together. So if I came here and used Alt Enter, you can see that I had 1, 2, 3 initially, 4, 5, 6 following, and then I got a brand new list, list 3, that has 1, 2, 3, 4, 5, 6. All right, so let's head over to arrays. So an array, just like a list, is also a sequence of numbers. So I can come here and say my array equal to 1, 2, 3, 4, 5. But unlike a list, right, an array, you can't really concatenate to an array like that. Unlike a list, you can't really change the size of an array, or by like adding new items to the array. The size of the array is fixed, but however, you could change, you can refer to arrays by value. So I can say array dot, and I can say give me the third element, which would be so if I were to highlight this and execute it, you see that the third element is number 4, or rather this is based on a 0 index, so that would be the 4th element essentially. Okay, so you could just refer to the item directly. You could also change the value as well using the assignment operator. Let's make that 6. So if I were to highlight this and execute it, you can see that it executed. And if I go back and run my array, you'll see that my array has 6 in it. This should in general be avoided. You shouldn't be mutating arrays in place except you really know what you're doing, but just wanted to point out that ability is there as well. Now that we've looked at arrays, the next thing we need to look at is the concept of a range. So a range in F# is essentially just a sequence of values. So if I can say, so all those values that we did before that were ordered in a particular way, you could also write it as a range. So I could do this that just says this is 1 to 5. I could also have a decreasing range. So you can say let count down equal to say 5 dot 1, so it's 0, right, dot minus 1. So what this will do is that the interval in which it is incrementing each value would be by -1. So that would essentially be subtracting 1 from 5 till it gets to 0. So if I came here and ran this, you can see it is 5, 4, 3, 2, 1. So ranges also work with arrays. So all these ranges that I've put here, if I were to come here and put this here, I would essentially get the same thing but with arrays instead. Okay, so another example of a range would be to count even numbers. So if I say even numbers equal to, I come here, say 1 dot dot 2 dot dot say 20. This would be odd numbers rather. So for even numbers I would do this, and if I run this, you see 2, 4, 6, 8 all the way to 20, which is cool. Yeah, you could also have ranges that are based on alphabet. So for example, I could just say A to Z, and if I run this, you see that it has all the alphabets A to Z. Finally, we're going to look at records. A record in F# is similar to a tuple, except that the values in the record are all named values. So for example, I could create a record type of person, and I can specify that it has a first name, string, last name, a string, and then I could easily say something like let John be equal to, say, first name should be John and last name will be Doe. Sorry, there should be an equal to here. It's not JavaScript. Equal to Doe. So with this in place, right, you could just execute this and you will see that the first name is John, last name is Doe. Makes sense. You could refer to properties of the record using something like this. So I can say John dot first name. So you can say John's first name is John dot first name, and that just returns in your John's first name is John, whatever. And you could also repeat that for the last name as well. So I could come here and say John's last name is John dot last name. Okay, if I execute that, you can see John's last name is Doe, just John's first name is John. So that's how you create a record. Now a record in F# is also immutable, so I can't actually, after John is created, come here and say something like this. Maybe just change his first name to something else, right? You can see immediately the F# compiler is really unhappy because this is supposed to be immutable. To fix that, what we could do, we could to update a record, you use this concept of update and replace or something like that. So for example, I could say let Jane, which is a different person, be equal to John, right? Copy and replace, rather. John with first name as Jane, right? And when I do this and execute this, you will see that Jane is now Jane Doe as well. So she's a copy of John but with a different first name. That is really important because types in F# are immutable. You also have the concept of anonymous record type. So if you notice here, we have to first declare first name. We have to first declare person, the concept of a person, then before we could start using John and Jane. What if we didn't want to do that? So well, you could just go ahead and say let point be equal to, and you use this similar to what we did with arrays. You use this pipe with your curly braces to just say x coordinate equal to 2, x coordinate equal to 2 and y coordinate equal to 3. So you have a point object, and as you can see, the type signature is telling us how it's composed. If I were to run this, it works as well. So you can see x is 2, y is 3. But the beauty of this is that we could say we could use the copy and update syntax. So let's say we can say let 3D point be equal to the original point with a z-axis of say 7, right? So you can use this to so we can put this here to create a 3D point, and as you can see, the type signature is also showing that you have a 2, a 3 and a 7 as well. So this is really useful because now we can easily change the shape of different records on the fly using anonymous records. That wouldn't be possible with, that's not possible with the standard records, but yeah, this is cool. So I think I'm going to stop here for today. I hope you learned something. We've been able to look at all the different values. We looked at we started with strings, tuples, numbers, and so on and so forth. So in the next video we are going to look at functions, and hopefully you will be able to start doing useful programs with that, because functional programming without functions is almost nothing. But I hope you enjoyed this video. If you like to, give it a thumbs up, and see you next time. Bye.